Okay, right. Good morning and welcome to the presentation today on modernization solutions for Rockwell automation users. We'll be introducing a phased migration strategy to optimize the update of your aging equipment. The presentation itself should last about 30 to 40 minutes, and you're welcome to chat, but you'll be muted by default. So there should be a chat button. If you've got any questions, please just use that facility to type in your questions. The session will be recorded and you'll be notified of the publication later on. Okay, so we'll make a start. The agenda today is very simple. I'll be introducing ProSoft Technology to you, going through some of the other webinars that are available from ProSoft. We'll go over some of the terminology used for upgrading or modernization and what it actually means to you. We'll go through the problem as we see it and how we can help you to solve it. And then I'll give you some examples of a phased migration approach and how it can be used in your strategy. And then finally, I'll go over some other solutions for upgrading legacy serial protocols, upgrading legacy competitive PLCs, and also legacy DCS systems to a PlantPAX system. And then finally, I'll summarize all the findings today. So, ProSoft Technology. We are a automation partner with many of the well-known automation vendors such as Rockwell Automation and Schneider Electric. We provide them with communication solutions for their in-chassis range and also for various sort of industrial protocol gateways as well as wireless solutions. We've been an industrial communication provider for the last 25 years and longer. And a lot of our customers are household names and major brands such as Caterpillar, Ford, GM Motors, Disney. And we operate in major key vertical markets, discrete, process and energy markets to help those customers. ProSoft Technology really knows industrial communication applications. We are application experts. We help our customers to connect, optimize, modernize, and migrate their systems. We are very customer focused. We are relentless in solving our customers' challenges, and our industrial customers trust ProSoft to do that. We are a great partner with our automation partnerships, and they are integral to our business. We make our partners more successful. So together with our partners, we optimize industrial productivity with innovative communication solutions. This webinar today is part of a series of webinars that we'll be holding with various sort of platforms. One is going to be on wireless solutions for automated materials handling, where we'll be able to talk to customers to optimize their applications such as AGVs, cranes, warehousing, etc. The other webinar will be on remote connectivity, which will be going over our cloud-based solution for secure remote access for the industrial Internet of Things age. And then we'll also have a presentation on our integrated flow computing solutions. So today, I'll be going over our modernization solutions. So the first thing to look at is what it means to either upgrade or modernize. So with upgrades, there tend to be a focus on a specific machine line or to address outdated technology. It's usually a smaller investment that provides a one-for-one replacement of the aging product. Typically, these sort of upgrades are more straightforward to do and require less budget and potentially come out the operation expenditure budget or OPEX budget. Whereas a modernization strategy could be more applying contemporary technology to address the issue of obsolescence or to improve productivity. And it's also setting the foundations to meet future business objectives. Typically, this is a larger investment with a higher return over time, but obviously this could require a more capital expenditure budget. So if we look at the problem as a whole, basically your plant has been operating for 10 years plus without many major sort of serious changes to it. It's also evolved, new lines have been added, etc. However, a lot of the assets that you have in that plant could be nearing the end of their life, and many of them could be going obsolete or discontinued. With Rockwell, there's a huge installed base of Allen Bradley SLC and PLC5 systems, and even remote I/O. And this legacy PLC could cause you lots of issues if something was to go wrong, causing a lot of downtime and stoppages. So how do we look at the problem? So first thing is to collect information, on the application itself. So we have a look at the machine, the line, through an installed base evaluation, and that's a very simple way to identify obsolescence risks. Then we analyze what we have on the plant, and we can determine where we can make the biggest impacts. We can identify your most critical equipment, where the biggest risks are, and what options we have. And then finally, we can plan how to address those issues. We can schedule in downtime, we can schedule in budgets to address those issues. So if we look at a traditional control system upgrade, a lot of those upgrades would be to install a new Ethernet network infrastructure, pull through Ethernet cables, convert programs, schedule downtimes for the entire upgrade of the entire system, rewire and commission system. But obviously, if something goes wrong, you've then got to debug the wiring, debug the PLC code, change the drive configuration and panel view configurations. So what happened? What could we do to change that more traditional approach? Is where we can look at it from a sort of phased approach. So a new Ethernet IP based system can be introduced with the existing networks or remote I/O networks in place in a phased manner. Those legacy assets can be migrated from one node at a time, scheduled downtime, saving you time and money. And once a legacy asset has been updated, it can be used elsewhere in the plant as a spare, minimizing downtime elsewhere in that plant. And also, during commissioning, if something goes wrong, you can put the legacy asset back in place. So what this means for the controls engineer is that they can be more reactive. They can replace equipment as it breaks. They can be more proactive. They can replace legacy equipment as it fits in with a maintenance budget, and they can manage spares more effectively. And it's a relatively quick option to do to keep the plant up and running in the event of an emergency. Also, the controller code may not have been documented as well as it should have been, and the person who did it may have left the plant, so it may be an option to leave the controller alone as much as possible. So let's look at an example of an existing plant and see where we can look at a phase migration. So we've done our install base evaluation, and we've identified a few critical areas of the plant, whether it's the aging PLC system or the aging DH Plus network, or the drives, the panel views, or even the I/O. And we can look at each of these aspects individually. So with a phased migration approach, we can look at the drives, for example. So you may have some older 1336 drives on your plant that you need to migrate up to the latest PowerFlex, which can then begin to introduce an Ethernet IP network through our gateway without making any changes to the ladder or code of the existing PLC ranges. So you're not changing anything on the plant, you're simply adding some new equipment. It may be that you've looked at the programming stations and SCADA screens, and the PCs there are old boxes with their ISA slots and old processors running older operating systems such as Windows XP or Windows 95, and you need to upgrade those to modern PCs with modern operating systems to run the latest SCADA systems or program packages while still maintaining the older programming package to keep the plant going for as long as possible. With the gateway, you can add in an Ethernet IP network and still use your existing Data Hub Plus network, using your existing PLCs, talking to the existing remote I/O network, but changing over the HMI screens to the latest PanelView Plus systems on Ethernet IP, talking over D8 Plus, or even talking directly to the remote I/O network. It may be a case that you're running out of spares for the Flex I/O ASB modules, and you can start to introduce an Ethernet IP network using the 1794 Ethernet IP adapters with minimal changes to the code. In fact, no code changes to the code. And then finally, you may think you want to change the PC over to a Compact Logix, for example, or a Control Logix, and maintain your existing remote I/O network, which you can do in a phased migration by adding in the new PLC, Ethernet IP network, changing the programming stations and HMI screens, but then still using it to keep your existing remote I/O network going for as long as possible, which is what they did in real life at a brewing application in South Wales, in Cardiff, at a Brains brewery. I don't know if anybody follows rugby, but Brains sponsor the Welsh national team. But they had a 27-year-old PLC2 system, which they wanted to modernize to a Compact Logix system. Their site standard was Compact Logix. So by introducing a Control Logix would have meant having to relearn a new PLC, have spares available, that sort of thing. So it's very important to them to keep to the Compact Logix. Also, they wanted to limit the downtime to just only 3 days. So they're going to retain their existing I/O racks, but also add a modern SCADA system. So what they did was to introduce the migration gateway and retain the existing 1771 I/O racks. What this meant for them is it reduced their commissioning. There was no changes required on the field wiring. It kept everything to the site standard with no additional spares needed to be held in anywhere. Also, the I/O data could now be accessed from anywhere on the plant network over Ethernet IP. And also, it was 40% less than the alternative solution. Before I move on, I'll open up the chat to check to see if there's any questions coming in. Okay, no questions at the moment, so we'll continue. Of course, if you have any questions, please feel free to ask them over the chat, and we can address those at the time. What I'll do next then is to move away from the phase migration into looking at sort of serial protocol legacy modernizations. The reason for this is obviously Rockwell used a protocol called DF1 for many, many years to allow customers to upload and download configurations as also for an interface to HMI screens with their PanelView systems, and also for radio modems. So as part of a larger infrastructure, it was used to as a sort of backbone between various different sort of modems, primarily used in the sort of water industry, built around that kind of DF1 protocol. And again, this legacy protocol is being phased out by Rockwell. Also, the new PLC ranges that are coming through now don't have serial ports on them. So we'll look at an example here of how it kind of fitted all together. So with the SLC 503 or 504, they had a DF1. Just to go back to the previous slides, do you need to take out the processor of an old rack to hook up the I/O? If you're doing the controlling the remote I/O rack in this sort of structure, yes, I believe you do. I think you need to have an ASB module to do this sort of, which is what they did in Wales. They had a ASB module to keep the existing rack here to hook up the I/O. Hopefully that answers your question. Any other questions at the moment before I move on? In this scenario, you can control the existing remote I/O network over the Ethernet IP network, but the customer in the other case wanted to retain the existing I/O rack, so that's why they needed the ASB module. Okay, so this is the existing network for the DF1 networks. So using the SLC to go through the DF1 program protocol to lease telephone line modems, going up then to a SCADA system or a HMI panel. So what the migration pathway or modernization pathway for this could be would be to update the RTUs into using the new modern Compact Logics PLC, which don't have DF1 ports on them anymore. So they can retain the existing infrastructure by using our modernization gateway here for DF1. So it's still talking to the SCADA system over DF1, still using the leased telephone lines over DF1, but then going into Ethernet IP. So you're beginning to modernize the RTU systems and also introducing the Ethernet IP network into it. Then the next step would be to upgrade the main SCADA system to Ethernet IP, but you're able to reuse the existing network infrastructure by using a second gateway. So now you can upload and download configurations over this network as well. And then stage 3 would be to replace the leased telephone lines with Wi-Fi radios or even 4G cellular gateways. So now you've completely modernized your existing infrastructure. However, an application example could be you want to change the panel views to the modern PanelView Plus systems from the legacy classic view systems, but retain the SLC. The SLC is still going, it's still very popular, but you may want to upload and download configurations as well. Any questions on the DF1 modernization before I move on? Could we use different protocols via Wi-Fi? Yes, you can use different protocols over Ethernet IP, over Ethernet packets. Also, you can use safety over wireless as well, and you can even encapsulate serial protocols with our radios over Wi-Fi as well, especially in the European Union facing Siemens. Yeah, you can use the Wi-Fi radios to do Siemens protocols as well as Rockwell protocols. It's simply Ethernet packets, so there won't be any issues in that. So finally, I'll look at a way to modernize competitive PLC systems and convert those to modern control logics or compact logics solutions. with these migration gateways, they enable Rockwell automation controllers via Ethernet IP to control legacy networks. You're able to monitor the network before you make any changes, so you can verify your code on your logics before controlling the existing Modicon I/O or existing Genius Bus I/O. That way, if anything does go wrong, you can put the legacy competitive controller back, keeping everything working whilst you re-verify the code, and then you can test it again and then put it back in to control. The controllers can go back in to control the existing I/O, and then you can begin to change the existing I/O one rack at a time. So it's for use as a phase migration strategy again. You can also use this strategy to change out legacy DCS systems. So you can upgrade to Rockwell's PlantPAX DCS system whilst retaining the legacy I/O. So again, you would have the interface card in the rack, which is monitoring the existing I/O. And when you're ready, you can change it over to control the existing I/O. Again, you've not really changed anything apart from adding a new PLC. So if something did go wrong or it wasn't quite working properly, you could then put the legacy controller back in place to control the I/O. Verify your code, and of course, if everything was okay, then you can begin to switch it back over to controlling, and then remove the legacy controller with the modern PlantPAX system. To summarize the presentation, we've looked at solutions to upgrade and modernize. We've tried to address the problem of obsolescence. We've looked at, obviously, solutions for legacy protocol modernization, and we've looked at solutions for competitive PLC or DCS modernization. So whichever strategy you choose, ProSoft have the application experience to advise you to plan your modernization to fit in with your budget, be it an operation expenditure budget or a capital expenditure budget. Again, I'd like to open up the presentation now to any questions. Okay. Let me just come through. Does ProSoft support services like pre-sales, on-site support together with the partner, and how should we proceed? The quick answer to that question is yes. We always partner with our partners, be it our local distribution or with Rockwell themselves. And we are able to go to site to look at the plant as a whole to help you with your evaluation of everything. And then we can proceed together. So the answer to the question is yes, we can help you either directly or through partners. What solution would you recommend for migrating ABB SAT line to Allen Bradley PLCs? That is a very difficult question to answer. We don't have an ABB SAT line out-of-the-box solution. However, we do have a series of application development modules where you can actually put in your own code into that, so you can actually write the code for ABB SAT line into that, either through the in-chassis solution or through a standalone gateway. We would also look at the other protocols available for the ABB system to see if there's another way we can get into that system, either through a sort of industry standard such as Modbus or Modbus T-SPARE-P, and to see if we can get into it that way. So it will be either through our application development modules or through a more standardized protocol to go and get into the Allen Bradley Ethernet IP network. Hopefully that answers your question. Are there any more questions I can help with? Okay, if anything else comes outside of the presentation, please feel free to email me at the address on the screen now, or telephone my mobile number, or even contact Maureen here at the Toulouse office, and we'll be able to obviously help you with any questions that you may have. And so if that's it, I'd like to bring the presentation to a close now. Thank you very much for all your time. Thank you very much for attending the presentation. Hopefully you've taken something out of it. And just to remind you that the presentation will be available shortly on download. You'll be given the links, etc., through the email. So again, thank you very much for your time. Thank you for attending the presentation, and we look forward to seeing you soon. Thank you.